You just require
takes no skill into consideration.
Yes, that's literally my symptoms are getting headache as soon as class starts and falling asleep. And my what to combat that, I just need people to carry me.
Yeah, anytime you see it stuff.
Yeah, and another one. Yeah,
that's
that's
another
another.
good.
Yeah, that's the hard route.
Oh.
Further ninjas out there.
Wait, sorry. Are you like eating gum like it's a? Put it all in your mouth. You don't. No. Oh my god. Madman.
What am I witnessing?
I thought you guys would have known that. I mean, like this from the serial video alone. Why is it surprising? I don't know. Why? Sean, have you not seen the serial video?
You're a weird dude.
I haven't seen you. I don't know you.
So have you not seen the serial video?
No.
Do you want to?
No.
No.
I'm good. I think I have a jail because he's next week.
This motherfucker microwaves his cereal in the morning.
Just tell me what
I thought that was normal.
You're not.
Yeah. You're a weird dude.
Why?
I'm diagnosed as
No, actually, why?
because
The ice wall milk in the cereal.
yeah, because usually it's too cold and straight out of the fridge. And this is how I grew up because both my parents were like coming to Australia for the first time.
Much holier, obviously.
I was only born 6 years after they came to Australia. We didn't really know what cereal was. I mean, we knew what it was, but like,
No
we
one
didn't know we
explained
weren't
how
supposed
properly
to.
eat cereal.
Yeah, we didn't know that we weren't supposed to microwave.
Okay,
Not
but
microwave.
this guy felt different taste, right?
And it wasn't like regular cereal like Amaro or anything. It was like wheat mix. And so then when you heat it up with milk, it's like porridge. So that doesn't seem so bad.
It makes sense not too bad.
Yeah. Wheat mix was the only cereal for me for like first.
But you
Eight, 9 years
microwave milk by itself?
No. No. I have milk. No. I put the wheat mix in. I soak it in milk, and then I put it in the microwave.
I've been here for 6 months and I don't do that shit.
Okay, good afternoon, everyone. Week 9, we continue with the concepts of beams. So the ultimate objective is you want to find the strength of the beam. That means how much you can load a beam before it breaks. And the tougher question is which part of the beam starts to crack? What is the most critical? And still we have to do some preparation because the beam can break either through the shear force or due to the normal force. Which one is dominant, we never know. You have to investigate. You only know that by investigation. And from case by case, that is different. So one of the key preparations that is to calculate second moment of area. And I want you to distinguish between second moment of area and second moment of mass. So when you do dynamic studies and you are dealing with the inertia forces, the parameter is second moment of mass. The unit is meter squared kilogram. That is what you had in energy and motion. So if you notice, the unit was not millimeter 4. And the formula for that was, we were, unfortunately, in terms of symbols, different books are referring to the same symbol with different meaning. So that was x squared dm. So here that was meter squared or length squared, that was kilogram. This is for inertia effect, something like when you have a rotational motion, I alpha does the torque. But what we use here, still that is called I, but we calculate this as a second moment of area, not second moment of mass. So this is dA. So length squared, so millimeter 4. That's what you're interested. And the most important thing you want to remember, that the larger I, the stiffer the beam. It means from the same material, if you manage to get a beam with a larger eye, that would be stronger. It breaks, you delay the fracture. We get to the material later on, but for now, this is purely geometrical thing. That is why we call performance has to do with internal load, and it has to do with the cross-section properties. Cross-section properties, let me clarify this. All right, so this cross-section is not a simple cross-section. That is a combination of simple shapes. You feel free to divide that into a number of primitive shapes. I give you a few scenarios. You could propose different scenarios. The question is, which one of these scenarios require less effort? So which one is smarter? So for this one, I mean, we can start breaking that into a number of shapes. For example, I mean, we do have we propose how to break it out in this problem. But before that, let's see how different scenarios can work for you. So one scenario is if I make a big rectangle to start it. So this is equal to that one. Then from here, I draw a line and then cutting that part. Then I end up with this one. And then let's subtract another triangle from it. That's one scenario. But the way we did it here is slightly different. So not sure which one is smarter. With this problem, I don't have any preference. So here we start with a horizontal rectangle plus a vertical rectangle plus a big triangle, and then minus a little triangle. All right, so this is not very perfect, and I'm not sure if we could perfect it more. But one thing I want you to notice is for the real beam, which is on the left-hand side, there is a reference. That reference, we show this by the dotted line. So physical meaning of that dotted line, it means that if you start to bend the beam about that dotted line, the upper and lower of the dotted line behave differently. Anything above would be in tension, the bottom compression, or vice versa. Therefore, this is your reference. And that reference, this is the first thing you calculate. We call Y bar. And then we want to bring the right-hand side, everything, these are primitive shapes. But just a question, is that okay if I bring the standard value from the table, from the formula sheet, and add them together? So for example, for this one, that is 1/12, this is B, this is H. That's what I get from the table. Is that, I can't use it. I mean, I can, but I have to pay a penalty, right? The penalty is here, to speak to this datum. This is my datum. Here, that's where the centroid is. So if you are bending this one, you would have assumed that it's going to bend with the reference over there. But in reality, the reference is here. So how much difference is here? That is called D1. And if I extend that line, so this is the same line, what is the center of here? Maybe the center is here for this shape, and that is D2. And what about this one? Maybe the center is here, right? If I extend that, it has a different offset. So let's call this offset 3. And with that one, you have something like D4. That's just a schematic. And then, yes, I can grab this one as 1/12 B prime H prime cubed. For this one, that is B second H second cubed by 36. That's the formula you get for triangles. And then for this one, you get something like, I don't know, B prime H prime 36 cubed. That is what you get from the table. But for each term, you have to add a penalty. So that is d1 squared by a1. That's the penalty you pay. For this one, the penalty is d2 a2. For that one is d3 squared a3. And for that one is d4 squared a4. Right. So this is very suitable for what we call this a tabular method. All right. So someone mentioned before that because the unit of this quantity I, the unit is millimeter to the power of 4, the chances are you have to deal with a very terrible, large, ugly number. And not one of them, you have to keep adding them together, and there are many, this is very prone for making mistakes. And one other property is whatever you calculate, for example, area is not only used once. You would be using the same area calculation over and over and over. How cool is that if you can transfer one calculation to the rest of the calculation, right? So if you fix it here, you fix it everywhere. But then if you make a mistake here, the mistake would spread everywhere. Not a perfect thing, but that's how we do it. All right, so that is in general, if you are given a composite shape, that we have a composite shape, just try your best to decompose it into the best possible scenario. And once you did, for every shape, refer to the table, bring the standard I from the formula, and then you calculate the penalty, add it to that, modify that table term, add it to the modified next, to the modified next, to the modified next. This could be plus minus, depending how you decompose it. All right, so that being said, yes, so this is how we do it, but what is the first step here? The first step, when you are given the composite shape, the first step is to find the reference, that dotted line. So how do we do that? This is also suitable for tabular method, because what you do is you say y bar is equal to a1 y bar 1 plus a2 y bar 2 plus a3 y bar 3, and then take a note here, I don't add a plus, I'm adding minus a4 y bar 4. And in the denominator, you put a1 plus a2 plus a3 minus a4. So don't be, this is not a universal formula. You have to take into account the plus minus sign. Okay? So that is the big picture. Now we go to the number crunching for that problem. And once we did that, anything else we do, even that is very suitable for what we call tabular method. Okay, what is tabular method? You write formulas in Excel in a table, and then underneath the table you easily can sum the number. If you have to multiply term and add them together, it's very flexible for that kind of thing, and that's what we will be doing next. So let's have a fast forward of how these things are being done. First of all, that formula is not correct. So here you should have a parenthesis. The sigma applies to everything. And here you put a bar. That bar means what you get from the table. And that is, well, here they call this y squared, they call this d squared. They're the same thing. So this, you could write this as summation of I bar, this is from the table, or standard I, plus d squared a. I from 1 to n, how many shapes you have. And that summation could be sum, could be subtraction. All right, so let's get this one started. First shape. All right, we found the reference to be 38. Anyone has a problem how to find it? That was the formula I gave you. If you put the numbers in it based on the division, this is shape number 1, this is shape number 2, shape number 3, and shape number 4. So 3 is here. 3 is here, 4 is here.
Three is just a bigger triangle.
3 is the bigger triangle, and 4 is a little triangle.
So basically, if you were to fill in where 4 is,
Yeah.
that's one triangle. That's 3. It's one giant triangle.
Oh,
with-
I see it, yes.
Basically with a whole bunch
So
of
the
rows.
3 is the whole structure.
Correct,
or is
correct,
that
correct, correct.
external part? Yeah, okay.
All right. Now, let's do this once for the yellow, which is number 1. Anyone can tell me where is the centroid of yellow? The centroid of yellow with respect to the bottom or datum. This is the datum, right? So the centroid of that is here, isn't it? That's 10. So if you want D1, that is D1, isn't it? So D1 is equal to what? 338 minus 10. 3367, that's 8. 3867 is the total. And then you take away 10 from it, that becomes D1. So this is D1 squared. That's the area. And this is the value, a standard value of a rectangle with a B of 80 and H of 20 divided by 12. All right. So now we are done with the first segment. So the first segment has been adjusted. Now let's go to the second segment. The second segment is this one. Who can tell me finding the offset here? The offset here, 100, the middle is at 50, right? So this is 50. But the reference is here. So the difference between that 50 and here, that is 50 minus 38.67. And that you have to square it and multiply it by A. Right? That's the penalty. And the starting part, that is 1 over 12. B is from here to here, which is 100 take over 80, that's 20. Multiply by H, which is 100 cubed. Now we finish the modification of the second piece. Now take, this is the third shape. This is the third shape, right? And with the third shape, careful where the centroid is. The centroid is 1/3 of the base. So if this one is 80, if this is 80, the centroid is located at 80 by, I just exaggerate to make this readable. So that is 80 divided by 3. So if the total is 80, this is 80 by 3. And then you have to add another 20 to it. So 20 added to 80 by 3. That is how far you are from the datum.
From the what, sorry?
From datum.
From like the
This is the baseline. This is the baseline. You have to measure. Y bar was measured from the baseline. So your centroid should also be measured from the baseline. And then that is the gap you are looking for. That is D3. This is the D3. That's the D3. And that should be multiplied by, well, no, not D3. D3 is here. D3 is this one. And that is the area of the tree. That's the area of the triangle. That's a standard value. For triangle, the formula is not BH by 12. That's BH cubed by 36. All right, now, eventually, you do that for the little triangle. But little triangle, keep in mind, it should be subtracted from the previous values. And eventually, you have all these things calculated all together. Now, let's go to page 322. And the question we have is number 18. Number 18. Let's see what number 18 is. This one. 2 minutes. Who can propose the smartest decomposition?
Would it just be one big box minus one small box?
Why that is smart? I mean, everyone listened what Taha said. Look, we could have done it differently. Let me do that in both ways. You see the difference, okay? So what he is saying is, so he is proposing this shape, this cross section is equal to that rectangle minus this rectangle. Why this is so smart? because,
That's what,
yeah, the centroid of this one is right in the middle, isn't it? If you extend, this one has the same centroid, this one has the same centroid, so you don't have to pay any penalty for it. I mean, someone could do 2 times a vertical wall plus 2 times a horizontal line. Okay, but at least for this one, you have to go and find an offset. You have to calculate the penalty. But eventually, you get the same number. This is just a matter of convenience, the matter of don't do something which is not needed. Let's go to page 323. Okay, here we want to calculate I for here. And this is a 2-part question. First, it wants you to find I with respect to the x-axis. The other one asks you to apply one with I with respect to y-axis. So what is the difference? The difference is with this very same beam, so if I apply my load like so, the bending takes place like so, right? So it is about that axis. But very same beam, in this case, load is Py, your I is Ixx. But if I apply P in that direction, this is Px, then you have to calculate Iyy. So load normal to the reference plane of the bending. All right, just memorize it. And in some problem, tricky problem, they just flip the shape, and students are used to take the horizontal line as the y-axis, but then for that they have to use I for the vertical axis. If that makes sense to you.
So is I the centroid of the whole shape?
I is not the centroid of the shape. I is a geometrical property which is reversely proportional to the performance. The larger the I, the better performance. Mathematically, I, Iyy, that is I with respect to the y-axis, that is x squared dA, but Ixx, that is y squared dA. So that's mathematical. Kind of difficult to interpret, but the interpretation is if you throw away that dA farther from the neutral plane, the larger the number. This is like when we had a I-beam, we try to stretch that, may make the area farther from the neutral plane. Let's do something which has some tough number crunching, something like this one. Okay, for first part, you want Ixx. Let's try together. And with that, I think we could start the tabular method with Excel. All right, so let's call this one number 1. That's Excel doesn't like annotator. So this is number 1. That is number 2, the entire box. And this is number 3. All right? Now, let me bring the formula you need and put the formulas next to it. Yeah. For a circle, standard I is pi d to the power of 4 divided by 64. for a triangle. This is B, this is H. So centroid is H by 3, and I is equal to BH cubed by 36. So these are from the formula book. Now, how method of tabular method comes into it? Let's calculate y bar first. So
Wait, what did you say was the formula to get the centroid of a triangle?
you get them from the you get them from the table. So
Then put x to y.
yeah, y bar is equal to y bar 1 a1 plus y bar 2 a2 minus y bar 3 a3, and that divided by a1 plus a2 minus a3, right? So now let me just make this one number 1, number 2, number 3. And this one, I call this y bar I. This one, I call this AI. And that one, I call this the products of yi, AI. And to calculate y bar, that is all I need. Let's see what's happened. Starting with first thing here. And then that is my datum. So my datum is, or my baseline is here. So with the first shape, triangle, the height is 200. All right, so the y bar for that is 200 divided by 3. Everyone can see that?
Yeah.
All right, so that is this one. For second one, what is the y bar? The y bar is 100. And for the third one, 100 again. All right, what is the area of the first one? That is 300 multiplied by 200 divided by 2. Everyone can see? That's the area of the triangle. And what is the area of the rectangle? That is 300 times 200. And what is the area of the circle? That is equal to pi.
How did you get it? 3,000?
How did I? I'm writing formula here.
Triangle area, which area of the triangle?
This is pi r squared. R is 75 squared. Okay, so that's area of the triangle, pi r squared, correct? So a little bit. Yeah, that's it. And now let's have the product. See how simple it becomes now. I write this as equal to this cell multiplied by this cell, and then enter. That's the fun part. You grab the handle, pull it down, and it calculates this for the rest of the cells. Right? And now for y bar, this is your y bar. This is equal to parentheses numerator. Numerator is plus this minus this divided by parentheses this plus area of the second minus area of the third, parenthesis close, and enter. So that is 86. Does that make sense? I mean, from rule of thumb, did you expect this to be below 100 or above 100? Yeah, below, yeah. So that is 80. Now we have the centroid. Now we have the centroid, that's great. So the centroid is here. .17. This is the centroid of the composite shape, the entire.
It's in the y-axis.
No, we found this because we are calculating IXX, so everything should be measured from the horizontal bottom line, right? All right, now, if you want to calculate I, a few more things you need. First of all, I have to add a new column here. That column, I call this, let's make this column a bit wider. All right, so that is, I put a standard I call this I bar. This column, we call this I bar. That means I bar I. This is what you get from a standard table. So remind me, what is that of the triangle? Let's calculate that together. This is equal to BH cubed divided by 3. That is 300.
Isn't it on 36?
We are talking about 1. 300.
Right.
300 times 200
Times 200 cubed.
divided by 2. Correct?
Base times height.
Area of the triangle. Oh, no. That is cubed. Yeah, you're right. Cubed.
Yeah, cubed on 36.
Divided by 36. I think I have to put this in a parenthesis. Otherwise, it might be misinterpreted. 36, right? So that is I for first shape.
Yeah.
So for the second shape, that is simple. That is equal to parenthesis BH3. That is 300 multiplied by 200 cubed.
Yep.
Parenthesis closed, divided by 12. And for the circle, that is equal to pi multiplied by d to the power of 4. D is 150 because radius is 75. That's 150 to the power of 4. And the whole thing divided by 64. All right, now the next thing I need is DI. DI is the offset. So DI. For the first shape, what is the offset? The offset is equal to this number here, that's the y bar, minus 1/3 of 200. 200 divided by 3. All right, don't worry about the positive, negative number. Eventually, that would be a square. With the second, the offset is for the rectangle, centroid is 100, is equal to 100 minus this number here. All right, and for the circle, that is also the same. Oh, no, I think I pasted the formula. Just have to do it again. That is equal to 100. Take away this one. Now, let's make a new column, and I call this new column DI squared. So that is equal to this term squared. And then you just pull this handle that would recalculate this for the next one. The last column, this is the penalty term. The penalty term is di squared multiplied by ai. And here I simply put equal to this multiplied by ai. ai is here. And you pull this handle, that would recalculate for everything. And here you just write II, that is the adjusted I. So the adjusted I is equal to table I plus penalty. And then you pull this down, but when you are, oops, yeah, it just repeated my shape as well, because the shape was sitting on the table. So let me just bring this away.
What's the DI, the difference between DI and DI?
This is penalty. This is penalty. We found the offset, we squared it, multiplied that by AI, just to repack them, make them ready for calculation. And now when you are finding the total I, just be mindful, you have to say this, so this, okay, so the total I is equal to this term plus this term, and the final, is this plus or minus the final? The final is minus, because you're subtracting that circle from it, is it? Minus the last one. Here it is.
So, penalty is different.
All right, so now let's go to another problem. All right, that is very similar. This is a practical shape. That's a T section. Actually, in the lab, we have also this kind of section. Let's grab this one. All right, first thing is to label the shapes. So I'm labeling this one as 1, labeling this one as 2. Only 2 shapes. All right, and first thing is to calculate y bar. So the y bar is simply y bar 1, a1, plus y bar 2, a2, divided by a plus a2. So let's start this here. You only have 2 shapes, 1, 2. So here that is AI. This one is y bar I. That is the products of AI, YY. Okay, who can help me with A1? A1 is 50 times 300, 50 times 300. Just watch me, I don't make a mistake. A2, oops, this should go here. And second, that is area is equal to 50 multiplied by 250. And then y bar 1. Who can help me with y bar 1? That is equal to 250. I'm measuring that from the bottom, plus half of the 50, which is 25. Correct?
Yep.
And what about the y bar for the first shape? That's 125. And then you just simply find the products of the previous two rows. And then if you pull that handle, it calculates it here. Now, let me just do the sum of the above. Sum of this term, that's the numerator. And then I do sum of the above here, that's the denominator. And then your y bar is numerator divided by denominator. So y bar is 206.8. Does that make sense?
Yes, see?
All right. Next, we want to find out the second moment of area. Second moment of area, let me add another column here. I call this I bar I. This is what you get from the table. Then I add another column for di, that's the offset. And then I make this di squared, or this one can be di squared, right? And here, ai, you already have it, di squared multiplied by ai. That is the penalty term. All right, so for the first shape, that is equal to 1/12 multiplied by BH3. So that is 300 multiplied by 50 cubed. That is I for the first one. For the second one, that is equal to 1/12 multiplied by 50 multiplied by 250 cubed. All right. And what about di squared? That is equal to the parenthesis this minus, for the first shape, what is the centroid of the first shape? That's 250 plus 25, that's 275. And that has to be a squared. The outcome should be a squared. And same thing with the first shape. That is equal to 125 minus that. We don't care if that's negative because this is going to be a squared and you get the positive number. Oh, I made, yeah, that's, that should be times. And finally, you want the product that is equal to this multiplied by AI. Approved. And final column, that is the adjusted I value. We call this I. This is not I bar I. This is a standard. That's a modified one. So the modified one is equal to a standard plus penalty. And then you pull this down. This one, you pull this down. And finally, the total I that is sum of these two totals. This is equal to that plus this. All right, we got the total. Yeah, just maybe later you can watch the recorded one and do it by hand. Yeah.
And then, is it di squared or di squared?
Di, I is the index.
Yeah, I is.
D1, D2, D3. That doesn't come into this. This is just a index. That's just the index.
So the value is
The value of D. Value of D corresponding to the second shape. Value of D corresponding to. All right, the last practice we have for today, that would have been something very cumbersome. If you want to do this manually, you find out how cumbersome that is. But thanks to using computers, like I said in the other units, so you engineers, computer is your slave. The more slave you have, the more powerful you are. All right? So you can make a pyramid without enslaving people. Enslaving computers, that's one.
Yeah, they don't This is their group. They're cheaper.
Okay, why do you know this?
Just wait for them to rebel.
Why do you know this? Shut up. You lived through it as the.
So this time, let's first of all, you have to label them. This is number 1. This is number 2. Oh, 1 is repeating twice, so let's make both of them number 1. That is number 2, and this is number 3. Does that make sense?
Is the bottom one not the exact same as never mind.
Well, geometrically, yes, but with respect to the distance from the center, they are not the same.
But you could use the same area.
Area would be the same. The area would be the same. Now, the starting point is you have to find y bar. So I write the formula for y bar somewhere in the corner. Let's see what the y bar is. Y bar is equal to 2 times y bar 1 times A1 plus y bar 2 A2 plus y bar 3 A3. And then divided by 2 times A1 plus A2 plus A3. Correct? Now, let's calculate the same thing here. You start with 1, 2, 3, and the first column could be your y bar 1, and the second y bar I. The second one is AI, and that is the products of y bar I AI. And yeah, all right. For the first one, what is, if I take that line as my baseline or datum, for the first shape, let's find out what y bar is. 100 plus 25 plus 50, that's 75. 175, right? 175. What is the y bar for the second shape? That is 112.5. And for the third one is simple, simply 50. And what is the area for the first one? Okay, area, I put a 2 in front of it to remind ourselves this is repeating twice. That is 2 times multiplied by 25 multiplied by 100. That's the total area. And with the second one, you have 325. The total is 325. So is equal to 325 multiplied by 25. And for the third one, that is equal to 25 times 100. And next column, you just simply multiply the previous 2 calculations. This multiplied by previous one. And dragging this handle. Now, all you have to do to calculate y bar, that is sum of these values divided by sum of these values here. And that is 122.5. Does that make sense? Not much. I would have expected this to be, yeah, maybe a little bit high.
But I think it's probably still.
Let's see where we made the mistake.
When we receive any questions where different shapes will have different weights.
Weight? That doesn't come to your weight doesn't come. This is only about the section property. Centroid, second moment of area, weight doesn't come into it. Yeah. Okay, we made a mistake somewhere. Let's find out. This number doesn't hold water.
It's still just over the middle.
It's very close to the middle, isn't it? But it shouldn't be in the middle because you have higher mass towards
Area.
Well, let's repeat. First one, the centroid is 125, 50, 175. The centroid for the second one, that is 112.5, the centroid 50. And the area of first one, that is I see. Yeah, in the denominator, we shouldn't have added AI together, or should we? This was counted twice, right?
Yeah.
Okay, this was counted twice, and
That would carry over to that.
well, I don't see anything wrong.
Maybe that's right.
Maybe that's right. Maybe that's right. All right, let's don't just wander too long here. We just need to add a few more columns. So the next column is I value, or a standard I, or maybe something tougher, that is DI.
Can we just do dx squared?
Wait, can you just do the results? Squared.
Squared. All right, so here, look, the problem wants you to report y bar with reference to that line in the middle. So in that case, your y bar would be 1225 take away from 100. So your y bar is 22.5. That is your y bar. So let me write this as a number. And now the next column, that's di. So for the first shape, the distance is from here to here, that is 25 plus 50, that's 75. 75 take away this number. And let's make this a square. All right, why bother repeating that column twice?
Wait, so D, wait, 75 take away 9.
So that is di squared.
So this is 75.
And for the next shape, that is equal to parenthesis. Well, that's 12.5 take away 22.5, which is 10 squared. That should be 100. And di squared for the last term, parenthesis. So that is minus 50, take away 22.5 squared. So that is di for the third shape. Because that's below the reference. We took the reference here that is adding. Eventually, they would add up. And then you want a column for di squared multiplied by ai. And that is equal to I think the penalty should be applied twice, isn't it? The penalty is applied twice, yes.
Twice the one, yeah.
That is 2 times that,
Di squared.
or because the area was calculated twice, you don't need that 2 here.
Yeah, I think it would carry over.
Yeah, we already accounted for that. So that is this multiplied by AI.
Sorry, what's F2? What form is that?
This is the cell number.
Yeah, cell F2, F7.
Yeah.
What formula is in that box?
So di squared.
That's a penalty. This is a penalty, yeah. The penalty is d squared multiplied by area.
No, he's asking for the di squared. What's the formula for di squared?
Formula for di squared, that's the centroid of the shape, take away from the centroid of the total shape, that's d. D squared multiplied by area of the shape. I think not C1. Multiply by this one, yep. And the next column is you have the standard I. So for the first shape, the standard I is equal to 2/12, because there are two of them, multiplied by BH3, 25, multiplied by 100 cubed. And with the next one, you have equal to 1/12 multiplied by 325 multiplied by 25 cubed. And for the third shape, that is equal to 1/12 multiplied by 25 times 100 cubed. And finally, you have the adjusted I. So this is the adjusted I, which is a standard I plus the penalty. And the penalty is here. And then that is calculated for three shapes. And finally, the total I that is equal to sum of these three figures, these three scalars added together. That is the total I. All right, you think that this is use of the computer? Yes, it is. But the very same thing would have been done more precisely, more quickly in SolidWorks. But the point is, SolidWorks is an expensive slave. Not every master can afford to buy that slave. This is a humble thing everyone can access. All right, we went faster than what expected because we were cheating using the computer. But that's quite perfect. I don't want to stop you from using that. All right, so you can do this. In the remaining time, I want to give you a brief head start for next week computer lab. So what do we expect in the next computer lab? So just very quickly, that is a simply supported beam. And the total length is L. And I have applied the point load eccentric. It's not in the middle. That is at the distance of A and B. So B is the distance from this side, A is from this side. The total A plus B is equal to L. And once you apply, every point of the beam would have its own deflection. The deflection, the symbol we use for the deflection, that is a lowercase v. That shouldn't be confused with the uppercase v. Uppercase v is for the shear force. Lowercase v, that is for the deflection. So I would give you a setup with the extensometer. So the beam, 1 meter beam is here, the cross section, this is the cross section. So for that cross section, you easily can go and calculate I. It is aluminum, I give you the Young modulus for it. And then once you apply that load of P, that deflection, you only can measure this at 5 points. Discretized points, 1, 2, 3, 4, 5. And once you tabulate all these, you can pass a curve to it and that curve will tell you exactly where the maximum deflection is. The maximum deflection should be near the middle, but not exactly at the middle, if that's eccentric. Now, I haven't covered the theory of the deflection for you. Don't worry. There is a formula book. Using that formula book, you should be able to estimate, if you know the P, A, B, L, E, I, you should be able to evaluate deflection at any point. Also, there are some formulas which tell you what is the angle of, what is the slope at the beginning, what is the slope at the end, right? So if I give you the formula is a function of P, A, B, L. You have everything, and you can measure theta from the curve fitting. So, question: if you put all these measured values, can you back calculate the load? So, I give you everything. You know how much A is, B is, L is, E, I, and you just measure theta. So, logically, you should be able to calculate P from that formula. Don't worry about derivation. This is just how to use the formula. Very simple formula. So 1P can be calculated from the left-hand side theta. 1P can be calculated from the right-hand side theta formula. And 1P can be calculated from the point value of Vx. 1P can be calculated from the maximum V formula. So you have 4 different estimations of the P based on the measurements. And how does this estimated P compare together? Ideally, they should be the same. And even more than that, if you just record all X corresponding to the V, and then you just plot them as a line, 1, 2, 3, 4, 5, and then you pass a line to it. From the slope of this line, you should also be calculating P. So that's what we do next week, same time, the computer lab. And from that, your estimated values will be compared, discussed, and then even you can calculate M at a certain point using that deflection. If you have deflection, that deflection could be correlated to the bending moment. So instead of you do a free body diagram finding the bending moment, also from the formula you can find where that maximum is, and from that we do some fun. All right. So that is all I had for today. I almost lost my voice. Let me just finish the attendance before I pass away.
You record this class. Saying. Wait, so on the topic of slavery, how was your years of
That's quite legitimate. That's quite legitimate. Don't worry.
did you record this class?
Yes, I did.
You gonna go on YouTube? You gonna put on the YouTube channel?
Yeah, put it on YouTube channel. Maybe. Well, in a matter of 10 minutes, that is available from Collaborate Ultra.
Oh,
But you can get it from Collaborate Ultra. Then I might need some time to put it on YouTube.
yeah. I'll call you. It's just because I want to take basically the ones we did class by hand.
Yes, yes.
Because we won't have Excel in the test.
Yeah. Maybe you could.
Will there be similar questions to those in the exam?
Easier.
Easier.
But definitely there will be one, yeah.
Go hard or go home.
That's something predictable. You wish there will be more of that.
Nothing changes. There's no reason to restart and turn it on. Just turn it on.
Wait.
Sounds like superstition.
Who restarted and turned off?
Rarely, but
Why?
I usually just
That's just fucking superstition.
I just restart and then fill the laptop.